All right, let's jump right into one of the most fundamental topics in microeconomics, how firms operate in competitive markets. If you've got an exam coming up, you're in exactly the right place. We are going to break down every single graph, table, and formula you need to know step by step. Let's get to it.
So here's our game plan. First, we'll get the lay of the land in the competitive firm's world. Then we'll get to the heart of it all, maximizing profit. After that, we'll tackle the tough calls in to produce or not. From there, we'll zoom out and go from firm to market supply, and finally, we'll see how it all works in motion with market dynamics over time.
Okay, first things first. Before we can analyze a firm's decisions, we have to understand the world it lives in. What does it actually mean for a market to be perfectly competitive?
It really boils down to two key things. One, you have tons of buyers and tons of sellers. And two, the products they're all selling are pretty much identical. The best example? Milk. You've got thousands of dairy farms and millions of consumers. And let's be honest, milk is milk. Because of this, no single farmer, not even our Vaca family dairy farm, can just decide to charge more. They're at the mercy of the market. They are what we call price takers.
Okay, this table is super important, so let's really dig in. Look at that price column. It is stuck at $6. It doesn't matter if the farm sells 1 gallon or 8 gallons, the price is $6. That's the price taker rule in action. Total revenue is simple, just price times quantity. Now check out average revenue, that's just total revenue divided by quantity. So at 4 gallons, $24 divided by 4 is, you guessed it, $6. It's always the price. But here's the real kicker, and you need to burn this into your brain. Marginal revenue. That's the extra revenue from selling 1 more gallon. Going from 4 to 5 gallons, revenue jumps from $24 to $30. That's a $6 increase. See the pattern? For a competitive firm, price equals average revenue equals marginal revenue. P equals AR equals MR. This is the key that unlocks everything else.
All right, now for the million-dollar question. Literally, how does a firm figure out exactly how much to produce to make the most possible profit?
Let's put ourselves in the farmer's shoes here. This table is our decision-making dashboard. The magic happens when you compare two columns, marginal revenue, which we know is always $6, and marginal cost, the cost of producing 1 more gallon. Okay, look at the first gallon. MR is $6, MC is only $2. Should we make it? Absolutely. We just added $4 to our profit. How about the second gallon? MR is $6, MC is $3. Still a great deal. We make it. We keep doing this as long as the revenue from the next gallon is greater than or at least equal to the cost. At 4 gallons, we get $6 and it costs $5. Good, let's do it. But now look at the fifth gallon. MR is $6 and MC is also $6. The change in profit is 0. This is our signal to stop. If we made a 6th gallon, it would cost us $7, but we'd only sell it for $6. We'd lose $1 on that gallon. No way. So the profit maximizing quantity is exactly 5 gallons.
So, what did we just discover in that table? It boils down to this one beautiful, powerful rule. Produce up to the point where marginal revenue equals marginal cost. MR equals MC. That's the golden rule. If you remember one formula from this whole explainer, make it that one. It's how every rational, profit-maximizing firm thinks.
And here's what that golden rule looks like on a graph. It's so elegant. The flat horizontal line is our market price, which is also our marginal revenue. That upward swooping curve is our marginal cost. So where do we produce? Right where they cross, at Qmax. Think about it. For any quantity to the left, like Q1, the revenue line is above the cost curve. That means we're making a profit on that unit, so of course we're going to produce more. Now look to the right, at Q2, the cost curve is above the revenue line. We're losing money on that unit. Time to cut back production. The sweet spot is always where MR equals MC.
Okay, so we know how much to produce when things are going okay. But what happens when the market price tanks and we start losing money? This is where managers earn their pay, making the tough calls.
Now, this is a classic exam topic, so listen up. Shutdown and exit are not the same thing. A shutdown is a short-term move. Think of a restaurant closing on Mondays. It's not producing, but it still has to pay rent, right? Those are its fixed costs. The rule is shut down if the price you're getting for your product doesn't even cover your average variable costs per unit. An exit, on the other hand, is the long-run decision. It's permanent. You sell the restaurant, fire the staff, you're out for good. No more costs. The rule here is to exit if the price is consistently below your average total cost.
Let's see that shutdown decision on a graph. So a firm's supply curve is basically its marginal cost curve. But here's the catch. Look at that U-shaped average variable cost curve, the AVC. If the market price falls below the very bottom of that curve, the firm can't even cover the per unit cost of its workers and raw materials. It's literally losing more money by staying open than it would by just closing the doors and only paying rent. That's why the firm's true short-run supply curve is only the part of the marginal cost curve that lies above the AVC curve.
Now let's look at the long run. The logic is the same, but now we're comparing the price to the average total cost curve, or ATC, which includes everything: rent, salaries, the whole shebang. In the long run, you have to cover all your costs to survive. So if the price is stuck below the minimum point of that ATC curve, you're not a viable business. You're going to exit the market. So the firm's long-run supply curve is the part of the MC curve that lies above its average total cost curve.
And what's really cool is we can actually see the profit or loss right here on the graph. In panel A, the price is above the average total cost at our profit-maximizing quantity. The height of that green rectangle is the profit per unit. The width is how many units we sold. So the total area of that box, that's our total profit. In panel B, it's the opposite story. The price is below our average cost. We're losing money on every single unit. And the area of that red box is our total loss. It's a super clear way to see the firm's bottom line at a glance.
Okay, we have spent a lot of time focused on a single firm. Now, let's zoom the camera out. How do the decisions of thousands of these individual firms add up to create the supply for the entire market?
In the short run, where the number of firms is fixed, this is pretty simple. You take the supply curve for one firm, which we see in panel A. Then, to get the market supply in panel B, you just add up the quantities supplied by every single firm at each price level. So, if we have 1,000 identical farms and each is willing to supply 100 gallons at a price of $6, the total market supply at $6 is just 100,000 gallons. You're just adding them up horizontally.
But the long run is where the real magic of competition happens, because firms can freely enter or exit the market. Think about it. If firms are making huge profits, that's a signal. Other entrepreneurs will see that and say, hey, I want in on that. So new firms enter. That extra supply pushes the price down. The reverse is also true. If firms are losing money, some will give up and exit. That reduces supply and pushes the price up. This whole process of entry and exit only stops when there's no more incentive to do either, which is when economic profits are driven to exactly zero. That happens at the special point you see in panel A, where the price is exactly equal to the minimum of the average total cost. The incredible result? The long-run market supply curve shown in panel B is perfectly flat.
Wait a second. Zero profit? Why would anyone bother staying in business to make zero profit? This feels wrong, right? This is a huge concept, the difference between economic profit and accounting profit. An accountant just counts the actual money coming in and going out. An economist counts that, plus all the opportunity costs, like the salary the farmer owner could have earned doing something else. So when we say zero economic profit, it means the firm's revenue is covering all its cash costs and it's compensating the owner for their time and investment just as well as their next best option. The accountant would actually report a positive profit.
Okay, time to put all these pieces together. Let's see the whole system in action. What happens when a competitive market gets hit with a sudden shock? So we start here in what we call long-run equilibrium. Everything is stable, the market is at point A, the price is P1, and every firm is producing at the minimum of its average total cost. They're all making zero economic profit. No one has a reason to enter or leave the industry. It's all calm.
Then suddenly, a new health study is published that says drinking milk is amazing for you. Demand for milk surges, shifting the curve from D1 to D2. In the short run, the number of farms is fixed. So with way more people wanting milk, the price gets bid up to P2, moving the market to point B. For all the existing farms, this is fantastic. The price is now way above their average total cost. They ramp up production, and they start earning juicy, positive economic profits.
But those profits act like a giant flashing neon sign that says, "Opportunity here." Entrepreneurs see this and start opening new dairy farms. As these new firms enter, the market supply curve starts shifting to the right, from S1 to S2. This flood of new supply starts to push the price back down. And this process continues. More firms enter, supply increases, and the price falls until the price is driven all the way back down to its original level, P1. We end at a new long-run equilibrium at point C,
The market now produces way more milk in total, but each individual firm is right back where it started, making zero economic profit.
Now, that perfectly flat long-run supply curve is the textbook model. In the real world, it sometimes slopes upward, and there are two main reasons why. First, some resources might be limited. You can't just make more prime farmland. As more firms enter, they all compete for that land, bidding up its price and raising costs for everybody. Second, firms might have different costs. The first farmers in the market might be the most efficient. To draw in new producers, the price might have to rise to make it worthwhile for people who have higher costs of production.
So let's just step back and appreciate what's happened here. The relentless force of competition, of firms entering and exiting, drives the market to an incredibly efficient outcome. The price consumers pay gets pushed down to the absolute lowest possible cost of production, the minimum average total cost. It's a powerful, almost magical result of how competitive markets work.
This model is our benchmark. It's the ideal of efficiency. But that leaves us with a huge question to think about as you continue your studies. If this is so efficient, why are so few markets in the real world actually like this? What is it about things like branding, patents, and technology that breaks this perfect model and allows firms to gain power over price? Answering that, well, that's the next chapter in your economics journey.